Good evening, folks. Thank you very much for being here at this session. Just want to check if you guys can hear me properly. Yeah. Thank you. So this is the first time that we're showcasing our solution at the MMS, so we're pretty excited about it. To introduce myself, I'm the product manager for the Cisco Nexus 1000E for Hyper-V. I work in the Cisco Virtual Networking Solutions team. And we have multiple folks from Cisco attending this event. We have Syed Gayoor. Syed, can you stand up? Syed is the technical marketing manager for the product. And we have Joseph Swaminathan. He is the engineering manager responsible for the SCVMM integration for 1000V. So we're going to talk about quite a number of products that we're planning to introduce with the Windows Server 8, which is recently renamed as the Windows Server 2012, right? So a lot of these are on the roadmap, and we want to introduce these products right at the Windows Server 8 timeframe or the SCVMM SP1 timeframe, just to mention that the timelines can be a little tentative. From an agenda perspective, I just want to, we've been working in the virtual networking area for the past 5 years. So we've seen quite a number of issues that our customers have been telling us. And I just want to briefly talk about the issues that we were trying to address when we introduced Nexus 1000V. And briefly talk about the architectural details around the product and how the architecture really addresses the issues that virtual networking really creates, and the portfolio of products that we are bringing to the Hyper-V environment. We are not just bringing a switch to Hyper-V, we're bringing an entire portfolio of products to the Hyper-V environment. So I want to briefly talk about the portfolio. And finally, what it really means for the customers. A couple of details about that. So I know this session is keeping you from the party and the beer, so I would like to be as crisp as possible. Hopefully I can finish this session in another 60 minutes. So if you are interested in the solution, 1000V solution, or any of the Cisco products, we have another session in the same room tomorrow around managing UCS, or the Unified Computing Servers, with PowerShell and SC tools. So please do attend that session if you're interested. And also just want to mention that this particular solution, we have a demo available on the show floor in Cisco booth number 300. So please do come by if you want to have a demo of this product. Like I mentioned earlier, we have quite a number of customers. We have been selling data center gear for quite some time. Ever since data centers existed, we've been selling data center Ethernet switches. So a lot of our customers right now are moving from physical to virtual for obvious reasons. The financial benefits associated with virtualization, the mobility, where you can move virtual machines from one server to another server, and of course, you can have better server utilization because of virtualization. So quite a number of customers are moving to virtualization. And of course, cloud brings many more advantages in addition to server virtualization. You have multiple tenants that can share the same physical infrastructure. You have elasticity associated with cloud that can really help customers to spin up and spin down the infrastructure or the VMs. But each of these environments present their own complexities when it comes to networking. So from a Cisco perspective, we want to make sure that we make this journey as easy as possible for our customers. So in that way, so we want to provide consistent interfaces across these three domains. We want to provide consistency from a feature set perspective. If at all something is available on any of our physical switches, we want to provide the same feature set across a virtualization and cloud environments. We want to provide consistency from a policy provisioning perspective. We want to provide consistency from a services perspective. And we want to provide consistency from a manageability perspective. If you have a management environment that can manage a physical Cisco box, we want to make sure the same management environment can manage the virtualization and private cloud environments as well. So if you look at the physical environment, like I mentioned earlier, we've been in this market for a long time. We, as per some of the analyst reports, we own about 75% of the data center Ethernet switching space. We have multiple switches. We have this Nexus brand of switches that are very popular. We have Nexus 2K, 3K, 5K, and 7K. And we are bringing the same feature set of the Nexus hardware switches to the virtualization environment using 1000V and VMFX. If you look at the network services front, we have quite a number of network services that we provide. We are either number one or number two in most of these areas. If you look at firewalls or ASA, adaptive security appliance, that's the most widely deployed, most well-trusted firewall appliance out there. We have ACE, Application Control Engine. There's a load balancer that Cisco sells. And we have WAS. There's an application acceleration solution for optimizing the WAN traffic. And you have a NAM, Network Analysis Module. So we have these appliances are pretty popular in the data center space. We want to bring the same appliances to the virtualization environment. So right now, if you look at some of these are already available for the virtualization and cloud environments. We are bringing that through tight integration with Nexus 1000V. We are also looking at adding more virtual services to Nexus 1000V. So we introduced UCS, or the Unified Computing Servers, about 3-4 years back. And we have been pretty popular. I mean, we gained quite a bit of market share in this area. We are number 2 in North America from a blade server perspective, and number 3 in the world for blade servers. Within a very short period of time, we were able to acquire quite a bit of market share. So UCS works fairly well for bare metal environments, but it's purpose-built for virtualization and cloud environments. A lot of our customers currently use UCS for building their private clouds. So by providing this consistent interface, consistent manageability, consistency in terms of feature set, we are making sure that we reduce the risk associated with the customers transitioning from physical to virtual to private cloud. Given that you are familiar with the interfaces, the CLI, the tools, the services, it's easy for it de-risks any kind of risk associated with your migration to either of these environments. Also, from a learning perspective, you don't need to, if you already have Nexus switches in your environment, you don't need to retrain yourself for a new operating system, new CLI, new services, new interfaces when you migrate to any of the other environments. So consistency really helps customers in terms of de-risking their investments when they're moving to the virtualization or cloud environments. So like I mentioned earlier, we have quite a number of products that we sell for the data center customers. We have the aggregation switches, core switches. We have routers, edge routers. We have network service modules that we sell to the data center customers. And these are deployed in production environments across a wide variety of data centers. We have customers that deploy these solutions in very small 200 server data centers to large enterprises deploying these in thousands of physical servers, to service provider cloud service providers. Some of the cloud providers that we are working with, they have huge number of VMs hosted on Cisco equipment, as in hundreds of thousands of VMs, and they're looking at about 1 million VMs. And we have massively scalable data center customers who are looking at huge number of physical servers, hundreds of thousands of servers. And we have quite a number of other verticals that are looking at specific areas, specific applications, specific types of data centers. For example, financial vertical wants low latency switching. So Cisco, our products work in each of these each of these environments, and we are this particular topology here shows a very simplified picture of a data center pod. So if you look at the just as very high level overview, you have the your servers connected to the top of the rack. The servers connected to the top of the rack switch. We call this access layer, and the access layers connected to the aggregation, the switches, and the aggregation connected to the core, and the core goes out with an edge router. That's not shown here. But we have products, and of course, because of the virtualization introduced a new layer called the virtual access layer. And we have products for each of these layers. We have Nexus 7000 for the core and aggregation, and we have Nexus 5000 for the access layer, and we have Nexus 1000V and the VMFlex solutions for the virtual access layer. So the most important thing for Cisco is Cisco provides this end-to-end networking stack for our customers. This is good from a multiple perspectives. As you know, quite a number of things are happening in the data center. Quite a number of new technologies are coming up. So all of these products use the same operating system. All of them use the same NXOS operating system. So from an economies of scale perspective, whenever we introduce a new technology in Nexus 7K, that will be automatically available in 1000V, and similarly, vice versa. So from that perspective, customers can utilize the economies of scale. We can pass on those savings to the customers. So coming back to the server virtualization, specifically network-related issues. Like I mentioned earlier, we have been looking at this space for the past 5 years. We have specifically evolved our virtual networking solutions around 3 important architectural tenets. We want to make sure that when the VMs move from one server to another server, the policies associated with those VMs, whether it be network policies, whether it be load balancer policy or security policy, the policy sticks with the VM throughout the life of the VM. That's something that we wanted to enforce. And we want to make sure that the VM to VM traffic is treated like any other traffic, in that you can apply policies, any network policies or service policies. And also, we want to provide enough visibility into that VM to VM traffic. As you can see, the orange dot in the picture is the traffic between those 2 VMs, but it might never reach the physical switch. In one analysis, most of the data center traffic these days, especially enterprise virtualized environments, about 80% is east-west traffic, or the traffic between the VMs. So if the traffic never reaches the physical switch, it really creates a blind spot for the network admin. For some reason, if the VM stops, the communication stops 1 o'clock in the night, it's very difficult for the network admin to debug what's happening. So we want to provide enough visibility into that traffic so that you can troubleshoot problems in the virtualization environment. And third is more from an operational perspective. We want to make sure that we provide operational segregation for the network admins and the server admins and the security admins. As in, we want to make sure that the network admin is responsible for network policy provisioning or network design across both physical, virtual, and cloud environments. And you should have enough visibility there. So one of the issues with server virtualization is most of the server virtualization management tools, they add a lot of additional burden onto the server admins in that they have to design the network policies, they have to design the security policies, etc. And the network admins don't have enough visibility into what's happening on the virtualization piece, right? So they have to design a network that has to, without having a lot of visibility into what's happening in the virtualization environment. So we want to make sure that our solutions provide enough visibility to the network admin so that they can design networks that can provide application availability for virtualization environments. So those are the three core issues that we want to address in all our networking solutions for the virtualization environments. And at the Microsoft Build event about 6 months back, in September, we announced that we'll have 2 specific virtual networking solutions available for the Hyper-V environments. So one is a completely software solution, Cisco Nexus 1000V. This provides advanced feature set for the virtualization environment with integrated services. And the other one is more of a hardware-based solution where you can splice up the NIC card into multiple virtual NICs, and you can bring the physical ports all the way to the VMs. So if you're looking for performance-oriented, if you want high performance environment or high throughput for your VM, then you want to go with the VMFX. Otherwise, if you want advanced feature set, you want to go with the Nexus 1000V. So I just want to briefly introduce the Nexus 1000V architecture. If you look at any physical modular switch that Cisco sells, we have 2 important components. One is a supervisor module. Actually, we normally have 2 for high availability. And this supervisor module is like the brains of the switch. You can log into a supervisor module and configure the entire box. It basically monitors the entire switch and maintains the health of the overall switch. And the second component of the physical any modular switch is the line cards. So we wanted to make sure that we provide the same architecture for the virtualization environment. So we moved the supervisor module, we made it into a VM, or a virtual appliance. So there's nothing but an NXOS running on a Hyper-V server as a virtual appliance. This can be running on any x86 server. And we moved the line cards all the way into the physical servers. So effectively here, each physical host becomes a line card. And as you can see, this is a highly distributed design, as in each of these servers can be anywhere in your data center. They can be on the same rack, they can be in multiple racks, or we actually tested designs where some of these racks can be across data centers, where some of the line cards can be sitting in one data center and some can be sitting in another data center. So this is a highly distributed architecture. And from a deployment perspective, a typical deployment of Nexus 1000V looks like this. So you have multiple servers here, 3 servers shown in the picture, and each of these servers are connected to the physical network like any other server. And each of them is running a Windows 8, actually Windows 2012 Hyper-V. And you have a VSM, the supervisor module, running on any x86 box on your data center. And you have SCVMM running anywhere in your network. As long as they're connected, it's good. And each of these Hyper-V instances, we embed the line card code. That's the we call it virtual Ethernet module. And the VMs on each of these physical servers are connected to the network using a construct called the virtual Ethernet module using a construct called virtual Ethernet port. So we made some innovations around this. I'm going to talk about port profiles in a minute. But we made sure that this is the overall high-level overview of the deployment of an Nexus 1000V. As I said earlier, it's a highly distributed architecture. And so the overall switch has multiple VIMs distributed across multiple physical servers with one VSM that actively communicates with the SCVMM. That is the overall architecture of the Nexus 1000V. So in addition to the switching functionality, so far we talked about the VSM or the virtual supervisor module and the VIMs that are laid out in each of these physical hosts. But in addition to that, we introduced a new component into the line card called vPath or the virtual service data path. It allowed us to extend the functionality of Nexus 1000V to multiple services, to offer multiple services on 1000V. So vPath does two things. It basically identifies if you want to apply a specific service to a traffic, to a packet, it identifies the service node where it should go, and it also does fast path offload. I have a couple of slides on that. I'll talk about it in more detail later in the presentation. But using this vPath, we introduced multiple services onto Nexus 1000V. We have VSG, the virtual security gateway, that helps you design secure zones within your virtualization environment. And we have VVAS, that's the application acceleration solution that Cisco provides. And we also have ASA 1000V available on the Nexus 1000V. In addition to the network services, we also introduced a physical appliance called Nexus 1010. So this came out of the customers asking for a physical appliance that can host any of these Nexus virtual appliances. In a lot of cases, the network admins don't have access to the virtualization management tools. So they wanted a separate appliance, physical appliance, where they can spin up these VMs whenever they need one, right? So this particular physical appliance team is designed to host each of these virtual appliances. So this is the complete portfolio that we are bringing to the Hyper-V environment. So we have VSMs and VIMs that form a distributed virtual switch, and we have multiple services, VSG, ASA, WAS, etc. And we have a physical appliance that can host any of the Nexus virtual machines. So that's the entire portfolio of products that we're bringing to the Hyper-V environment. In addition, we are also looking at multiple other services. And of course, we are also evolving the functionality, the switching functionality that's available on the switch, on the Nexus 1000V switch. So from a switching feature perspective, this is very similar to any other physical switch that you're, like the 7Ks or 5Ks or the 3Ks. So we have quite a bit of advanced switching functionality. We have QoS. From a security perspective, we have quite a number of security. We have PVLANs, we have ACLs, advanced ACL support, port security, dynamic ARP inspection, IP source guard, DHCP snooping. From a services perspective, like I mentioned earlier, because of the virtual services data path, we have virtual security gateway, ASA, and multiple other network services enabled on 1000V. From a provisioning perspective, I'll talk a little bit about port profiles. But we are currently working for tighter integration with SCVMM. So once you define, the network admin defines a specific policy on the Nexus 1000V, it's automatically propagated to SCVMM. So that really simplifies the provisioning, overall provisioning of the virtual networking. And from a visibility perspective, we have quite a number of new features. I mean, quite a number of features that we provide for the virtual networking. We have SPAN and ER SPAN available, and NetFlow, and we have CDP. From a manageability perspective, if you have an existing Nexus environment where you have any of the physical Nexus boxes, and you have some management tools that can support any of these Nexus environments, for them, Nexus 1000V looks like any other switch. So you have automatic day one support if you currently have a Nexus, any Nexus environment. So you can use the same SIM tools, you can use the same network monitoring tools, you can use the same network provisioning tools with Nexus 1000V. So management becomes a fairly easy task, especially for the network admins. So I want to briefly talk about the port profile. So if you look at a physical servers, typically physical servers, it takes about a month to rack, stack, and cable your physical servers. So physical server provisioning takes a long time. But virtualization, it really reduces the amount of time that you need to provision a VM. About a couple of minutes, you can have a new VM. We wanted to make sure that you can provision the network policies in the same time frame. Instead of taking a couple of days to provision the network policies for your VMs, we want to provision that within a few minutes. So with that in mind, we introduce this concept of port profiles. A port profile is a live template to encapsulate all your network policies. So for the network admin, if you know that there are going to be a specific set of servers in your data center, you have web servers, you have application servers. If you know that each of these fall into some specific buckets from a policy perspective, you can create policy templates in advance, and they're automatically, so the policy templates can include the VLAN information, the PVLAN information, port channeling, all the policy, network policy information. And you can create this template, and it automatically gets pushed to SCVMM. So when the server admin wants to instantiate a VM, it's easy for him. He can actually instantiate a VM and then pick the network policy that he wants to assign to that particular VM. So this is the workflow. So the network admin, he can create a port profile for that particular application, and then the port profile information is automatically communicated to SCVMM using, it's automatically propagated to SCVMM. And when the server admin wants to instantiate a specific VM, he picks from a list of port profiles, he can pick and choose which policies he needs to assign to that particular VM, and the VMs are automatically provisioned with the right network policies. There's not just network policies. The port profile can encapsulate all of the services policies as well, as in security, firewalling policies, load balancing policies, etc. So this is a very modular way to approach provisioning problems in a virtualized environment. So just want to check if you have any questions that I can address around the Nexus 1000V or any port profiles or anything. Please go ahead. Please go ahead. Can you please repeat it again? Sorry. Right. Right. So, Joseph, do you want to take the question?
So, with the new integration, there is going to be a...
Joseph, can you repeat the question? Just,
yeah. So, I believe what he, if I rephrase the question, we are publishing the port profile, and SCVM has a concept of logical networks, and in the host, how these two correlate and how things are done. What is the relation between the port profile and the logical network, and how it translates into provisioning the port? Is that on the switch?
Okay, that'll be great. Okay. Okay, that'll be great. Okay. I think there was another question here, sorry.
Yeah, it's not really related to what you're talking about right now. Is there a way to automate some of these commands when you're doing requirements? I mean, what good is having a vertical segmentation and private public cloud requirement? You've got your own memory configure.
That's a good question. We have multiple, we're working on multiple tools. We have a tool called NSM that can automate network policy provisioning. So NSM, Cisco NSM, or the Cisco Network Services Manager, and that can automate, yeah, network policy provisioning. So go ahead. 3 slides, okay. Okay, okay, okay. Any other questions about the port profiles, the Nexus 1000 functionality, architecture, etc.? Jeremy, you have any questions? So just want to move on to the services. We wanted to make sure that the way we design the services is in line with the virtualization, the requirements of the virtualization and the cloud environments. If you look at a traditional data center, right, I mean, you have multiple services that you want to use, and most of these are available in physical form factors, mostly 2 types of form factors. You have an appliance that you can buy, you can plug into your network, or these are integrated switch modules that can go into either a Cat 6500 or switches like that, right? So, but in a virtualized environment, especially when you're looking at secure multi-tenancy, this becomes a much more complicated issue. You require that from an elasticity perspective, you have to spin up any of these services at will. Whenever you are onboarding a tenant, it's possible the red guy might want specific set of services, a load balancer and a firewall, and the blue guy blue customer might want just a firewall. In those cases, I mean, how do you really make sure that you can instantiate these whenever you need to onboard a customer? And also from a scaling perspective, given that cloud requires automated scaling, should support elastic environments, it requires that you should be able to increase your throughput at will whenever you have, when you scale from 100 VMs to 200 VMs or 2000 VMs. How can you make sure that your services can support that throughput, replication, the number of transactions, etc.? So we kept these in mind when we designed the services architecture around Nexus 1000V. Currently, there are 2 ways in which you can provide this services for the virtualized traffic. You can use the physical appliances like an ASA 5585 or a ACE module or a WAS module, and use the virtual context on that particular physical appliance, and you bring out you assign a specific VLAN to each of the application types that you have and bring the traffic all the way down to the physical appliance and apply the service here. This is one model. A lot of our customers still use this model. But for Nexus 1000V, we follow the second approach, where we tried separating out the policy enforcement from the policy decision point. So we wanted to use the distributed, the computing power of the physical host to enforce the policies. So we introduced this concept of virtual service node. Each of these, the service node can be a firewall, a virtual appliance, a virtual firewall, or it can be a virtual load balancer, etc. So this is the architecture that we followed for the 1000V services modules, and this is good from multiple perspectives. From a scale out perspective, if you want to increase the throughput of your services, all you need to do is add one more hypervisor, one more physical host. If you want to increase the number of transactions that it can process, that the services can process, you just add one more VSN. So from an elasticity perspective, it really becomes easy. And also from a multi-tenancy perspective, you can assign these VSNs to each tenant that comes on board. So you can automatically instantiate each of these VSNs whenever you're creating a new tenant. So I just want to have a couple of slides around vPath, or the virtual services data path, and just want to outline the architecture that we use and how we are extending the 1000V functionality to services. So here in this picture, you have multiple physical hosts hosting multiple VMs, quite a number of VMs, and we have a service node called VSG, the virtual security gateway. And like I mentioned earlier, the 1000V, as part of the VEM modules, it has the vPath, or the virtual services data path. And this vPath intercepts every packet that comes into the system and make sure that if a specific service policy has to be enforced on that particular packet, it checks whether it has it sends the very first packet to the virtual service node. That's the virtual security gateway in this specific picture. And then the policy decision is made by the VSN, or the virtual security gateway in this particular instance. So VSG does all the computations, and it relays the decision whether to deny or allow the packet to the vPath. And vPath caches the decision and then enforces the policy. In this case, it is to allow the packet to go from an external client to this particular VM. So this is the typical flow of for vPath when you want to enforce a specific policy. The very first packet in any flow goes to vPath, and vPath redirects that to the virtual security service node, and service node makes the decision, and then it sends to the vPath, and vPath enforces the policy. But for subsequent packets in the same flow, this is much simpler. So since vPath knows that the packet is coming from the same source and it's going to the same destination, and it knows that decision already has been made, has been communicated to vPath, it basically enforces the policy locally. So because of the policy enforcement done locally, it basically, you can scale out your services much better than any other architecture. Sorry, so that's a mistake. So from a customer benefit perspective, the most important thing is consistency. We provide consistency across physical, virtual, and cloud environments. If you are familiar with the NXOS CLI, you can use the same CLI across your core switches, aggregation switches, access switches, and virtual access switches for your physical environment, virtual environment, and cloud environment. And from an operational model perspective, the network admin have visibility, complete visibility across the 3 domains, physical, virtual, and cloud. And we provide the same set of network services. So if you are currently using ASA or WAS, etc., you have the same set of services are available for you for your virtual and cloud environments. Just want to stop here and just want to check whether if you have any questions around any of the topics we covered. Jeremy, please go ahead. Does 1000V provide this? Right now, we are, so the question is around the integration between SCVMM and the Nexus 1000V, and if Nexus 1000V provides all the stats around the network traffic back to VMM so that VMM provides a central point for visibility into the traffic, right, Jeremy? So we are still working on, we want to make sure that there's as much tighter integration as possible with SCVMM. We want to provide the server admins with enough visibility so that they can see what's happening in the virtualized environment. But 1000V itself has quite a number of components. It provides quite a number of stats around the VM to VM traffic, etc. But to answer your question, we are working on that. So we are working closely. We've been working with the Hyper-V team for almost a year now, and we were able to get the VEMs and VSM integrated into the Hyper-V environment. Now we are currently working with the SCVMM team to make sure that the integration is perfect and to all the components, like what you mentioned, right? So we want to provide all of that visibility into SCVMM. We're working with them on multiple aspects. Some of them we are not sure if we can disclose because of the confidentiality between the SCVMM team and Cisco. So I didn't want to talk about the logical networks, etc., because some of them they're still in the works. Please go ahead. So if you look at the data center, 3-tier data center architecture, right? So we have multiple layers in the data center architecture. You have core switches, you have aggregation switches, you have access switches, and you have virtual access switches. So each of these layers require a specific type of feature set. Nexus 7000 sits in the core and aggregation layers, and the Nexus 5000 sits in the access layer, or the top of the rack, or the end of the row configurations. And Nexus 1000V sits right in the server itself. Any x86 box can host a 1000V. It sits in the virtual access layer. So that's the difference. Maybe I have a slide around that. Give me 1 minute. One of the first slides is around that. So just want to take 1 minute. Let's see if I can go there. This is the pod that I'm talking about. So there are multiple layers here. And 1000V sits in the virtual access. And 5000 sits in the access layer. There's a very simplified topology of a data center. Different types of customers use different topologies. Some of them, I hope I answered your question around the differences between 1000V and the rest of the Nexus family switches. Please.
Do the current and legacy Cisco products report to
Can you please repeat that question again? Sorry.
For auditing reports,
Uh-huh.
Center is hyper, in 2012, the Cisco hardware now would work better. Prior, we had been audited, we had to set up all kinds of reports. We had all kinds of data coming in, but we have nothing to give because
So that's still in the works. I mean, I think you're talking about the auditing, the question is around auditing functionality, whether Nexus switches support the auditing functionality available in the System Center suite of products. And the answer is it's still in the works. We're still looking at it, and it's on the roadmap. So. Any other questions around the virtual switch, any of the components of the switch, feature functionality, services? So the question is around which versions of SCVMM are we integrating with, right? So the Windows Server 8 or the Server 2012 will be supported by the SP1 of System Center 2012. So we'll be integrating with that. So most of the products that I'm talking about are work with Windows Server 2012. So we are working with the System Center Virtual Machine Manager team, SCVMM team, and we'll have a beta version available sometime in August for with the full integration. We're looking at multiple things, starting from the integration around all the networking aspects of SCVMM, including some of the things that Jeremy mentioned, including, I think there was a question around logical networks. We are looking at that. So we want to make sure that it's a fully integrated solution. So I mean, we want to make sure that the operational model is pretty seamless. The network admins, the interaction between the network admin and the server admin is as painless as possible. That's what we want to make sure. So we're looking at, right now we are running a beta, we're running a joint beta with Microsoft, but without the SCVMM integration. But we're looking at another beta coming up in August, September timeframe, where we'll have the completely fully integrated SCVMM stack. So 1000V with SCVMM with Hyper-V on Windows Server 8. Any other questions? Just wanted to check how many of you heard about 1000V before coming to the presentation? Oh, most of you. Okay. Okay. Another question again, how many of you currently use SCVMM in your environments? SCVMM 2012. Okay. From a 1000V front, I mean, I think there were a couple of integration questions, but just wanted to check. Do you guys currently use SCOM or any other products, System Center products? You currently use? Okay. Okay. Okay.
With the current management integration
Okay. Dude. Okay. Okay. So SCOM integration is something that you would be looking for when it comes out. Okay. 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 Thanks for the feedback. Okay. We are. It is on the roadmap. We are definitely looking at it, and. Any other questions around any of the topics covered here? I mean, please go ahead.
Integration if you're running robust infrastructure, running SAT traffic over Ethernet.
Mm-hmm.
Is this something coming for Windows 8 area, the UCS platform? Can the power that boost?
With the for the converged.
You have the virtual SaaS which things.
Okay.
Is there anything from Cisco in that area?
So the question is around the converged traffic and the support in Windows Server 8, whether UCS boxes, especially Palo adapters, do they support that? I need to defer that question to Syed, or do you know? Yeah. So we are the VMFX team is currently working with the Hyper-V team as well as with the SCVMM team, and we are making sure that there's a strong integration when Windows Server 8 comes out. And I think some of that maybe, unfortunately, we don't have the expertise here, so we'll definitely answer your question maybe at the booth. Any other questions, please? Okay. So given that we are introducing this solution for the first time, we're showcasing this solution for the first time at MMS, we kept it very high level, and we will make sure that the next presentation or the next session on the same topic will be at least a 300 or 400 level topic. And we have a demo available for each of these components. I mentioned about quite a number of products here. I spoke about the VSM, from a portfolio perspective, I mentioned about VSG, WAS, VSM, WEM, etc. All of these are available in the demo in the booth, Cisco booth. So please do come to the booth so that we can showcase how VSG operates, how DCNM works, how NAM works, etc. And also, I just want to mention that we are currently working closely with the System Center team on the UCS front. So we have SCOM integration, SCVMM integration, SCCM integration for UCS. If there are no other questions, so maybe I'll conclude the session. Just want to give me 1 minute. So we have quite a number of additional resources available online. So if you're looking for additional information about the Cisco Microsoft partnership, please do visit cisco.com/go/Microsoft. On Nexus 1000V itself, for Hyper-V, we have a white paper, a solution white paper on 1000V for Hyper-V. And given that we're still at least a couple of quarters away from the product launch, we don't have a lot of information. But if you have any specific questions, please do reach out to the team here. We'll be available for answering your Q&A at the booth, at the Cisco booth. So please do come by. And thank you very much again for coming to the session. And please do sign in. And What's that? Oh, 2 slides, you want to go back? Okay, sorry. This one? This one? Sorry, okay.